Okay, so today we are going to be talking about ratios and proportions. So, what is a ratio? A ratio is a comparison of two numbers using division. So, if we want to write out a ratio of x, oop, 1 second. So, if we want to write out a ratio of x to y, we have a number of ways we can write this out. We can either say the ratio of x to y directly. We can write it out as x colon y. And lastly, we can write it out as a fraction, x over y. So these are all expressions of the ratio of x to y. Alright, so if we have two ratios that are equal, we call those a proportion. So, or at least a equation stating that two ratios are equal. So, for example, if I have a over b equals c over d, this equation is a proportion. So, one thing that we'll be doing is determining if ratios are equivalent. So, if we have something like 2/3, is 2/3 an equivalent ratio when compared to 24ths? So, are these equivalent ratios? Now, there's a number of ways to find out. What I would do is I would set them equal, make it a possible proportion, and then see whether or not this equivalence is true. If it's true, then they are equivalent. If it's not, then they aren't. So I would take this equivalence, and let's see what happens if I multiply both sides by 24. Get 24 over here, 24 over here. These cancel. Multiply both sides by 3. So multiply this side by 3. Multiply this side by 3. This 3 and this 3 cancels. And so what I get is 24 times 2 equals 48 equals 16 times 3. So that would be 48. Since this is true, this is a valid proportion, and that means our two original ratios, 2/3 and 16/24, they are indeed equivalent ratios. Alright, the other way, and this might be a little bit easier just looking at it, is, let's see if we can write our ratio. So let's go again, 2/3 and 16/24. If we can find a value that we can multiply top and bottom of this fraction or this ratio to get to this value, then we will have equivalent ratios. So let's see, all we really need to do is ask ourselves, what do we need to multiply 2 by to get 16? Now obviously there's a way we can find this every time without fail, and that's just going through a division problem. And we would see that we would get just 8. So 2 times 8 equals 16. So let's see, we won't even worry about that. Give us 16. Now, if we can multiply 3 by 8 and get 24, we're good, and as it turns out, 3 times 8 is 24. So this is also an acceptable way to see if these are equivalent ratios. Alright, so if we have two ratios and we equate them together, so let's see, 1/2 and 2/4. If we make this a proportion, set them equal, we can write these. I think it might be helpful to write this as 1 to 2 and 2 to 4. We have different terms for the outside values in this proportion. These are our extremes. And these inside values are called our means. Now, there is a property of proportions that we call the means extremes property of proportions. This property states that if we have two ratios that are equal, so if we have a proportion A, B equals C, D, we can write, or we know that the product of our extremes is equal to the product of our means. So we know A, D equals B, C. So let's see. Let's really quick work through and see why that is. We can write our ratio as A over B, and this ratio we can write as C over D. And so, simply assuming that B and D are not 0, if we want, we can multiply both sides of this equation by D. Our D's cancel over there. Then we multiply both sides by B. Our B's cancel here. And we get A, D equals B, C, which is really what we have in our means extremes property. So really, the means extremes property follows just about directly from looking at our proportions using ratios in the fraction terms, or using fractions to express our ratios. So with that being said, let's see if we have something like two ratios, 2 over 3.5 and 8 over 14. If we want to find whether or not these are equivalent ratios, what we can do is we just invoke this means extremes property, and we say that we know that 2 times 14 must be equal to 8 times 3.5 for this to be a proportion and for these to be equivalent ratios. So let's see if that's true. 2 times 14 equals 28. 8 times 3.5, that would be 24, 5, 6, 7, 8. So that would be 28. So we are good here. This is verified. This would be a proportion, or I guess 2 over 3.5 equals 8 over 14. This is a proportion, and since this is a proportion, these are equivalent ratios. Good. So let's try another example. 0.3 to 1.5 equals, or let's assume they equal, 0.5 over 2.0. And here I say we're assuming they're equal, in all reality we're testing to see if they're equal. We're looking to see if they do make a proportion when combined with each other. So let's test this. Let's see, using our means extremes property, we know that 2 times 0.3 should equal 1.5 times 0.5 if this is a proportion. And so 2 times 0.3 is 0.6, and then 1.5 times 0.5 is 7, oop, my bad, 0.75. These are not equal, so this would not be a proportion, and that means these are not equivalent, what would we call them? Equivalent ratios. Okay, so with that being said, we can use our means extremes property to determine whether or not two values are equivalent ratios. So, with that, a little bit about a new term, or a new word that we call rates. What are rates? A rate is using ratios to compare two values that have different units. So if I want to compare, let's say, the cost of gasoline, so $3 to every gallon, so 1 gallon. This would be a rate. This is the rate of gasoline, and we would write it out as we could write it out as $3 per gallon. So this is an example of a rate. This is actually an example of a unit rate where the value that is being compared to, one of the values being compared to, has a value of 1. So this is a rate, and what's more, it is a unit rate because we have 1 gallon of gasoline. We are comparing some amount of money to 1 unit of gasoline, 1 gallon of gasoline. So what are some other examples of rates? We could have 10 meters to 13 seconds. And so we could write this out as 10 meters per 13 seconds. And sometimes you'll even see where we will somewhat simplify this out to 10/13 meters per second. Something like this is quite common to see. So that's an example of our rate, and our unit rate is just whenever we make one of the units that we're being compared to 1. A lot of times what we'll say with this will be 10/13 meters per second. So this would be kind of an example of taking a rate and turning it into a unit rate just by saying that we have 10/13 meters per 1 second. And what we'll say for this is 10/13 meters per second, or 10/13 meters to 1 second. Okay. So let's see here. If we have or let's consider a problem where we have, in the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3? So we know that in 2 years, we have 232 retail stores to 2 years. So this would be stores to years. And so we know that we have 232 stores to 2 years. And we can write this out as a proportion where we have an unknown number of stores but we know that it's going to be to 3 years. And so we can just solve for this r. Well, in order to solve for r, all we would do is simply multiply both sides of this by 3. 3 years, really. And so 3 years on both sides. Our 3 years cancels over here. The years cancel over here. And what we're left with is 3 halves times 232 stores, and that will give us the number of stores, which is 348. So there we used our rates in order to find out how many stores would open up in 3 years if we know that the number of stores to open up in 2 was 232. Okay. So, let's see here. Similarly, we have an idea of scales. Scales and scale models. A scale is something that is used to make a scale model. A scale model is something that we make to make a large thing more manageable. So like a map would be an example of a scale model. So when we have a scale, a lot of times we will say that something like 1 inch on our scale equals 10 miles. So we have a ratio, or let's see here, we can turn this into a ratio. We say that 1 inch over 10 miles, this will be our rate. 1 inch to 10 miles. So, this is our scale. Now, if we want to know how many miles are in 10 inches, so, or let's say 1.5 inches. If we were to want to see how many miles would be in 1.5 inches, we would simply solve this proportion. And so how would we do that? Well, we would multiply both sides of this by r, miles. I'm just going to use mi. The r's cancel over here. Then I'm going to take and multiply both sides by 10 miles and then divide by 1 inch. So I'm going to multiply both sides by the reciprocal of this fraction. So let's see here. That would get rid of this entirely. So r miles 1 inch over 10 miles. And I'm going to multiply it by 10 miles over 1 inch. These are going to cancel out. And on the other side, I'm going to have 1.5 inches. These things canceled out, so I'll leave those gone. And then 10 miles over 1 inch. The inches cancel. And I'm left with r in miles is going to be 15 miles. So in our scale, where 1 inch equals 10 miles, if I have 1.5 inches, we get 15 miles, which makes sense. But that's the procedure that we would use to solve for any type of relationship with a scale model. So with that being said, I hope that makes sense. I think maybe it might be helpful to work through one other example of a real life kind of scenario maybe. So let's see here. If I'm driving in a car and every 3 hours I go, so 3 hours to every mile, or let's say 2 miles. So I have 3 hours to every 2 miles, and I want to know how many hours I go in 25 miles, or how many hours does it take to go 25 miles. And so simply, I would write out my proportions, get my equivalent rates or equivalent ratios. I am looking for an amount of time, so I'm going to just call it t. So t hours, and I have 25 miles. And so, again, it's simply solving for t. We have 25 miles down here, so we would multiply both sides by 25 miles. These cancel, and the units here and here cancel, and we're left with 75 over 2 miles, or my apologies, hours equals t in units of hours. And so t, the time, is going to be 75 over 2, and so that would simply be, let's see here, 275, so that would be 3, 60, 15. Now we would make this 7, 14, 1, and so this would be 37 and 1/2 hours. So if it takes 3 hours to go 2 miles, it'll take 37.5 hours to go 25 miles. And really, that's what a lot of these problems will kind of look like. You'll be given a rate or a ratio, so 2/3, and then you'll be asked that if you have a proportion where the numerator is 7, what is the denominator? Or if the, so same setup, if the numerator is unknown and the denominator is 7, what is the numerator? Most of the problems that we come across in this chapter are going to be of this form. There'll be a little bit of a setup, and that might be kind of the difficult part, but really it's all about looking for what are the rates that we are going to set equal to each other to get a proportion, and then it's as easy as just solving an equation with one unknown. Hopefully that makes sense. If you have any questions, please let me know. Thank you very much for watching.